Hi to all, I hope you're all doing really well. In this video I would like to show you how you can greatly improve the rendering quality of FreeCAD's 3D view with the help of a add-on called Arc Textures and the 3-point lighting technique. Moreover, in this video I'm using a 3D connection 3D mouse that was kindly sent to me for testing and feedback for the 3D connection team, as they want to have a perfectly functional device for FreeCAD 1 release. They closely worked with the FreeCAD team for this integration, and it is really great to see that big players are taking FreeCAD seriously in the CAD software scene. A in-depth video review will follow with instruction on how to set it up on all three major platforms. With this out of the way, let's get to it. By default, FreeCAD's 3D view is quite plain. It has only one light source, and in the latest revisions of the software, this can be configured in the Preferences dialog. We will use this ability to configure the source of light in conjunction with a add-on called Arc Textures to achieve what it is called 3-point light studio lighting. So let's set up our workplace. The first thing to do is to go into Tools, Add-on Manager, and search for the Arc Texture Workbench. I already have it installed, so if you don't have it, please go ahead and install it now. The next thing to do is to go into Edit Preferences, and the relevant voices in the preferences that we need to tweak are in the Display 3D View, Light Sources, and also in Part Design, Shape Appearance. So let's start with the Display Light Sources. In this window, by simply dragging this arrow here, we can adjust the direction of the main light in our scene. We can adjust its color and its intensity. Also, one thing that I like to do is to go into Display Colors, choose a linear gradient for the background, and tweak it based on the particular light or dark theme that you use. Also, we have in Part Design, Shape Appearance, the default view properties of an object at its creation. Based on your particular project, you can tweak here the various properties, and we will see later in the video how these properties, especially shininess, ambient color, and specular color, affect the rendering of our scene. If we search the Wikipedia page for 3-point lighting, we can see that a typical 3-point lighting setup is composed of a main key light, a fill light, and a backlight. This type of lighting helps controlling or eliminating the shading or shadows produced by direct lighting. To demonstrate the 3-point lighting in FreeCAD, I will use these two models with different features in order to demonstrate the basic concepts, and in the last part of the video I can show you how you can go really complex with the lighting of a scene. As we've said earlier, we need 3 sources of light, and the first step is to set up our key light. Our key light is our main scene light, the default light in FreeCAD, and we will set it using the Preferences, Display Light Sources. As per our diagram, I would like our key light to shine from the top left of the screen towards the bottom right, something like this. And I will, in this part of the tutorial, I will use colored lights to make you understand how they affect the scene. Click Apply. Okay. The color of our body is this neutral gray here. The color of our light is blue. To have a better understanding of what's happening in the scene and how the various properties affect the display, by selecting our body and then going into the Property View tab, in the selection we can select the selection style to be as a bounding box. This will eliminate the highlight of the selection. The second step is to go into the Arc Texture Workbench after we've installed it. The Arc Texture Workbench offers the possibility of creation of 2 types of lights, a point light or a directional light. We lack two sources of light, so I will create them by clicking this icon, 1 and 2. And if we select one light and use the spacebar, we essentially turn it on and off. One thing to note is that this directional light have geometry in the 3D view. So if we use the fit all icon, we are thrown way out in the scene, showing our the geometry of our lights, and this little speck here is our body geometry. In order to exclude the lights from the fit all function, we can wrap them into a part container. We will create a new part, let's rename it as lights, and let's throw them in. Now if we hide the lights container, if we use the fit all option, you can see that the fit all option fits only the visible objects. Now let's quickly see how different lights affect our scene. Our main key light was color coded as blue. I will use this directional light and I will rename it as fill light, or perhaps for clarity, fill directional light. And the last one, I will rename it as back directional light. So F2 on the keyboard. Let's select the fill directional light. Into the data tab, I will color code it with a nice strong red color. And the back directional light, I will color code it with a nice strong green color. If we select our directional lights, we can see that we have properties for intensity, we have properties for the horizontal rotation and the vertical rotation. Initially, these properties are kind of hard to understand how they affect the placement of our lights. But if we unhide our lights part here and we do a fit all, let's change to the top view and select our fill directional light. If we alter the horizontal rotation value, we can see how the light rotates around our subject. Now we are in top view. We have set it up our main fill light to the right of our subject, and of course we need to place our backlight using the horizontal rotation value. We will place it as per our diagram in the back of our subject. Now if we change the view to front view, again this little speck here is our scene. Select the fill light. If we alter its vertical rotation, we can see how it changes position in our scene. The same with our back directional light. Just imagine these two lights that we have in our scene, that they are stuck to an imaginary gigantic sphere, and the horizontal rotation rotates on the XY plane, and the vertical rotation will rotate vertically, always touching this imaginary sphere here. Now let's hide again our lights part. If we do a fit all, we can see the main blue light that illuminates the whole scene. We can see our fill directional light that illuminates the right side of our object, and the backlight should illuminate with green light. So if we take it a look from the backside of our object, we have our green light. One thing to notice is the backlight will illuminate the underside of our object, and we will take advantage of this strange property of the backlight. Okay, so with this theory in mind, let's go ahead and set up a new scene. The first thing to do is to go into Edit Preferences, and we will set up a real scene with correct light colors. So I think the direction of our lighting is quite good as it is. I will give it this light a white color, and the intensity at 90% like this is pretty much right. Let's apply our changes. Okay. Our body here, if we select it, go into Property View, View tab, has this color here. I will change its selection styles to bounding box in order to see how the different properties affect the render quality. Notice how at this moment we have the ambient color, specular color and emissive color to set it up to a perfect black. The shininess also is set it up to 100. I will move into the architecture workbench. I will create a new body, a new part rather. I will rename it as lights and I will create two directional lights, 1 and 2. Let's move this light inside our part 3 item and let's do a fit all. The fit all option, you can find it here in the toolbar also. Let's move to the top view. This little speck here is our scene. I will rename our first directional light as fill light and our second directional light I will rename it as backlight. Let's select our fill light and relative to our scene, I want to place it somewhat at a 45 degrees position here to the right. So select our fill light, the data tab of the property view, the horizontal rotation will be something like -45 here. Instead, if I select the backlight, I want to place it in the back of our scene, so select the horizontal rotation and let's place this somewhere here in the back of our scene. We will move to the front view and what I want to do is to lower the position of these two lights as they illuminate the scene a little bit from too high away. So our fill light, I will lower it to something like 30 degrees and our backlight I will lower it to something like 30 degrees also perhaps. Hiding the light part, we are now again into our main scene. Let's choose the isometric view and what I really want to do is to highlight the various geometry of our object in order to better help our perception of depth. One thing that I can do is to select our fill light and give it a color that will enhance the differentiation of the different angles of our geometry. I will change its color to something like this, and this salmon color here will be in contrast with the main white illumination of the scene. We can change in the directional lights, we can change the intensity, and also if we alter the vertical rotation, we can make it a bit more direct on our object. Let's give it a bit more saturation. Okay, let's select now the backlight, and the backlight will have a great influence, of course, in the back of our object. And to see this, I can change the color of this backlight to something really strong, like here, like this. So the backlight has influence on the back of our object, but a property of this backlight is that it will illuminate the underside of our geometry. If I turn it on and off, you can see the effect. So I will change the color to something like this. Okay, the intensity is at 1, but we can play with the intensity to obtain the desired effect. Again, even here we can play with the various positioning of our light in the scene to obtain what we want, based always on our geometry. Let's toggle on and off our lighting and see how it affects our scene, the backlight and the fill light. Now I think it's time to go into the view tab of our property view and select our object, and let's take a look a little bit of how the ambient color, specular color and emissive color affect the rendering of our object. There are two properties that affect the shininess of a object. So I will select our object, property view. Of course there is a value called shininess, but another value that affects greatly the rendering of our object is the specular color, especially the value here. If the value is set to a really low number, there will be almost no reflection on our geometry. If we want low reflectivity or even no reflectivity in our geometry, we need to select the specular color and give it a really low value. In this case, I will have it a complete black, and our surface will mimic a material like a really low reflectivity plastic. Okay, so now let's quickly take a look at our next scene and see how we can replicate the aspect of a stainless steel-like object. We have our 3-point lighting set it up already. Let's hide our part that contains the light, fit all. If we select our object, this body here, let's go into the property view, selection style, bounding box. We can see better how the various properties affect our scene. Into the diffuse color, I've chosen this color here. The ambient color at the moment is something like black, and the specular color is something really shiny, but that resembles a lot the base color of our geometry. The shininess property will affect the specular effect on our geometry if the specular color is set it up to a value higher than 0. With a shininess high, because we can go up to 100, the specular will be really concentrated. If we lower the shininess, you can see how the specular becomes more diffused throughout the geometry. Let's set up the shininess to something like 20. This should be our fill light. Let's go into the data panel. We have a 50% intensity. We can make it higher. Another property that you can tweak to get your desired result is the ambient color. If we change the ambient color to a value higher than 0, and let's change the color just for you to see the overall effect. The ambient color will influence uniformly the whole geometry in all directions, independently of all the other values that we've set previously. So you can use this property to your advantage also. I will set it to black again. And this is how you can enhance the display of a stainless steel-like object. In this last part, let's see how we can really go complex with the lighting of a scene. For this, we will use a different type of lighting offered by the Architecture Workbench. And this is the point light. I will create a part. I will rename it as point light, and I will create 2 point lights in our scene. Let's select them and let's drag them inside our point light part. If we select our point light here into the data tab, we can see how we can alter the location of our light source. So let's change to our front view. And let's place our light to a 100 millimeters or perhaps 200 millimeters height on the z-axis and 200 millimeters on the x-axis. Switch to the top view and let's place it somewhere here, 45 degrees relative to our scene origin. This should be minus 200 millimeters perhaps on the y-axis. Let's select our backlight and let's do something like Z200, Y200 and X minus 200. Let's name this as front light, this as backlight. And for demonstration I will add another light here. Let's drag it into the point light part, switch to the top view. Let's alter its position property. So we have 4 light sources in our scene if we count the main default light in FreeCAD. Now, because we have placed our lights inside a part container, we can hide the geometry, but we can alter the properties nonetheless. Let's give it a different color to our backlight here, something really strong, like this. And I will play with the intensity. I want my backlight to mimic the same warm feeling of the scene. Okay, intensity, let's lower the intensity. You can see how it lights this top part of our object, and of course it affects the back of it also. And we can also alter the properties of the front light. Let's give it a bluish color, perhaps a lot less saturated, and we can alter the intensity. And we have a really nice effect a really complex lighting in our scene. One thing to notice is the properties of this geometry here. In the view tab, we have a specular color that is quite light with a shininess of 50%, and we can see the reflections of the light on the steel part of our 3D mouse. But if we select this object here, we can see that we have a specular color that is black with a shininess set to 100, and we have no reflections because that knob is a soft touch rubber. In my opinion, 3-point lighting or more light sources should be integrated into main FreeCAD because it really enhances the quality of the 3D display. Anyway, with this new acquired knowledge, I hope you can all go and create some beautiful scenes that will make for some beautiful FreeCAD Release 1 screenshots. This is all for now, and I'll see you in the next one.